Hello there and welcome to Year 8 Mathematics. Now, in recent lessons we've been doing area of a number of different objects. We did square, rectangle, kite, trapezium. Yeah, what else is in there? Rhombus. Circle. Circle was the last lesson. So today there are two things we need to do. Firstly, we're going to do areas of part of a circle. Things called sectors, which can be, any amount of a circle. So we're going to do the area of a sector. And secondly, we're going to do the area of composite shapes. A composite shape is when you've got multiple shapes combined together. And that's going to be a little bit more challenging, but we're going to give it a go, aren't we? Yeah, we're definitely going to give that a go. So, here we go. First off, we're going to do the sectors. Now, from yesterday, do you remember what the area of a circle was? We did a formula for the area of a circle. Do you remember that?
No.
Yeah. Oh, they were full circles yesterday, not those. They're like parts of circles that were drawn there. Yeah, pen. Anyway, so the area of a full circle, if you remember correctly, the full circle, so ones that look like this, the area was pi r squared, where r is the radius, that thing in the middle there. And we had to be careful because sometimes we've been given the diameter rather than the radius, and we needed to make sure in that formula that we use the radius. Well, these things are part of a circle. See, if I took a circle and chopped it out about there, I'd get something that looks like that. It's a sector. Or if I got a circle and took a bit out there, I'd have that's a somewhat downward looking Pac-Man or something, right? It's called a sector formally. Now the formula for these recognizes that they are part of a circle. And do you remember how many degrees are normally in a circle? We take all the way around the circle. How many degrees are in a circle? Hopefully one of you out there remembers that it is indeed 360 degrees. The formula for the area of a sector takes this into account. It basically says that the area of this sector is going to be a proportion of what the full circle would be. The full circle's 360 degrees. Oh, just wait a sec. I'll get you. Yep. All right. Okay, well, say bye. Say bye. Okay, don't say bye. Anyway, so pi out of 360. What? The area is going to be a proportion of the full circle. So we need two things in this formula. We still need the radius, but we also need to put the angle in, right? So the angle that's inside of our circle that we want the area, the area of. Magic, that's hopefully solved. Now, here we go, guys. The reason we have this part out the front is the area of part of a circle. Well, it's part of a circle, and this here creates part of a circle. For example, if I had half a circle, in a half a circle there's 180 degrees. That would make it half out the front because 180 over 360 is a half. So this just makes sure that the area is a proportion of the full circle. Now, most importantly, you need to be able to use that. So firstly, we need theta. Theta is the angle inside the circle there. In this case, it's 130 degrees. So I put 130 degrees in as theta. All right? So that angle is theta. And this measurement here is from the radius, from the full circle. So we put in our angle, 130 divided by 360, multiplied by pi, multiplied by the radius squared. You are more than welcome to put that full thing in your calculator. There we go. I can see where my calculator was dumped. That's nice. All right. So now I've got a less exciting calculator today. I hope you'll be all right. So 130 over 360 times pi times 5 squared. All right. On these Casios, it's very easy to just write in exactly what we have on the board. If you don't have something that's so nice, you can put division between the 130 and the 360, right? That's 130 divided by 360 times pi times 5 squared. It's exactly the same thing if you don't have that button there, all right? So I press equals, and I'm told that the area is approximately 28.36 meters squared. Remember to use our units there, and it's squared because it's a measure of area. Now over here there's a deliberate trick in it. The angle that you need, so this is another sector, it's another part of a circle, it's almost a full circle, but the issue is that the angle you need is the one that you're calculating the area for. That angle there is outside of the sector. The angle we actually need is the one inside the sector. So to get that, how could I possibly work out the angle in here first? That's the angle we want, the angle that's actually in the sector. To do that, you need to remember how many degrees are there in a circle? 360, right? So that angle there, that angle plus that angle have to add up to 360. So in short, the red angle there will be 360 take away 40. Take away this angle there, giving us 320 degrees. So that 320 degrees is the red angle in there. Notice how now it adds up to 360? Okay? So we needed the 320, the angle in the sector, before we could use the formula. There's a whole question of ones like that in the text, so we just needed to be clear on that. Next up, we're going to go area. As always, we write the formula. I understand this one's a bit more challenging, guys. It is a bigger formula, but you can do it. And now we just drop in the values. Theta we just worked out is 320. Pi is still pi. The radius this time is 7.2. We have to remember to square it. So all I've done there is I've got the formula and I've dropped in our theta value and I've dropped in our radius value. From there, you're welcome to go back to your friend the calculator. So here's what you do without the fraction button. As I was hinting at before, I could just write 320 divided by 360 times pi times 7.2 squared. And there we go. I'm going to draw the approximately here because we are rounding at some level. As always, I'm rounding to the second decimal place. I notice that rounding isn't everyone's friend. Second decimal place there is a 6. I look to the next digit. If it's a 5 or more, I'd make that a 7 back there. But because it's a 4 or less, I leave it as it is. I'll leave that as a 6 as the second decimal place, all right? And our unit, centimetres squared, because it's area. So that's the first part of what we needed to cover. That is finding the area of a sector. The second part of the lesson is area of composite shapes. I'm going to give 2 examples of that before letting you go off onto your own. We'll be right back. And we're back for the second half of the lesson now. Yep, okay, you can run. Now, composite shapes. So composite shapes refer to shapes that are put together from multiple other shapes. So we've looked at a number of basic shapes. I've listed them out before: your square, your rectangle, your triangle, your trapezium, your parallelogram, your kite, your rhombus, your circle. Anyway, if you combine 2 or more bits of those different objects, you get a composite shape. Now these things are a bit harder to find the area of course. And this is a little bit more challenging. But let's have a go. As examples I'm going to go through, I have 2 of them in front of us. And they are made of different objects. Now, here we go. This thing here has got 2 objects. Can you tell which objects they are? It's a rectangle and a triangle. While this one over here, this is a bit weird. There's this big chunk taken out of it. I hope it looks clear enough on your end. But what I've tried to do there is a square. You see those little marks mean they're all the same length? I've tried to make a square there with half a circle chopped out of it, a semicircle. Yes, we're going to do more. Now, here we go. So, what I'm going to use here to find the area is, it's going to be a rectangle. I'll actually write the words. I'm going to go, it's an area of a rectangle plus a triangle. Now, if you look back on our notes from recently, you will remember what those formulas are. The area of a rectangle is length times width. The area of a triangle is 1/2 base height. Right? So we have done them by a triangle. No, we're not getting rid of the triangle yet. All right? So in there you need to appreciate that the area of this whole shape will be, well, the surface here, the area of this, the surface here, plus the surface here, will give us the total surface, right? And that's what area is. It's like the surface. So that's why I can say the area will be that rectangle plus that triangle. Now let's put the values in. And I've done one thing tricky to you here that I hope you're going to notice before I do it. Now first let's look at the rectangle. Now it has a length of 7 and a width of 4. So I'm just going to put that in. And then the triangle, hang on, what's the length of the base of the triangle there? It's not 10, 10's the full distance across. How will I work out what that distance is? Just there, just that base of the triangle. Can you see it? It's going to be that whole 10 take away that 7. What's 10 take away 7? It'll be 3. That's important for our calculations. So 1/2 times the base, which is 3, times the height, which is the same from the rectangle. The height there is going to be 4. So 7 times 4 is 28. Order convention, remember we do multiplication first. 1/2 times 3 times 4. You can put that in your calculator if you want, but it's not that hard to do manually. 1/2 of 4 is 2. Times 3 will give us 6. 28 plus 6, the answer is 34 millimeters squared as a measure of area. Remember it was in millimeters and it's millimeters squared. If you went and drew little millimeter squared blocks out of that, in theory you'd end up with 34 of them. Really? Go, play with this one. There you go. It's awesome. Alright, second one. Now this time we have a square, but we have to subtract half a circle. So in this one we added it because we had this surface plus this surface. In this one it's a bit different. We've got a square, but then we've removed half a circle. So it's going to be subtraction. So the area this time is pretty well a square, subtract the semicircle. The area of a square, I believe we did as L squared. And we also did the formula for a semicircle of half a circle. We did that in the previous lesson as 1/2 pi r squared. So it's half of the normal circle area. Again, we need to put the values in. And again, there's something that might appear to be slightly missing here. Now, as all these sides are the same length, they've given us this. That's going to be 10 meters. But that, if you think about it, is the diameter of the circle, and we need the radius, right? Remember, this formula uses the radius. So if 10 is the diameter, what's the radius going to be? Half of it. So the radius is 5 meters, and that's the one we're going to have to use in our formula. Remember to be very careful with circles, right? Whether you're dealing with R for the radius or D for the diameter, you've got to make sure you're on track with that. So let's go ahead. The square, the length of the square was 10, so we're going to get 10 squared, subtract 1/2 times pi times the radius of our circle. Radius was 5. So that looks all rather hideous, but we're going to just throw it in the calculator, all right? So I put the calculator on, I go 10 squared, take away 1/2, times, remember to use the proper pi button in your calculator because it's more accurate, times 5 squared, and that's what I get. Remember again, a half I could also put in as 0.5 because it's the same as a half, but I'm happy enough with this. Second decimal place, you get 60.73. It was all in meters, so in area terms it will be meters squared. These are more challenging examples. There are additional examples in the textbook if you wish to look at them. Now I'm just going to get the recommended questions and I'll then set you free for today. Thank you for watching. So students, here we are yet again, and yep, that's it. Please go forth and practice the area of sectors and composite shapes. And look, please send me a message if you've got any questions and we'll see what we can do. So remember, just take a very close look at those composite shapes. They are shapes you've done before. Look back over the notes of what we've done in class and our examples and give them a go. And you say bye. Say bye. Oi, are you going to say bye? Nah, not happening. See ya.